In section 22, we're going to be looking at an introduction to sequences and something called summation notation, which is a topic that can only be applied to sequences. So to start this section off, we're going to look at example 22.1. It says to graph the function, and we have a function definition provided, much like what we saw at the beginning of the semester and we've been working on throughout the course of this semester. We have an equation, f of n is equal to 3n minus 5, and notice that we have a domain of the natural numbers. The other thing that you might notice is the equation is an equation that we should be pretty familiar with. F of n equaling 3n minus 5 is going to be linear. It would take on the mx plus b style of equation that we saw earlier in the semester. I believe it was section 6 is where we saw the introduction to linear equations and linear functions. But because the domain is natural numbers, making a table might be the best way to go about doing this, getting this graph complete. So we'll make a table, and the left column will be n, the right column will be the f of n, and I can only plug in, again, natural numbers, so that'll be things like 1, 2, 3, 4. I'll put dot 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 because we could continue that for as long as we needed. And then I'm going to be substituting in these individual values. When I plug in 1, the value that we map to will be -2, 2 maps to 1, 3 would map to 4, and then 4 would map to 7. And that pattern would continue as well for the f of n values. So coming over here to the graph, I'm going to plot these points, and if I plot them correctly, I should be able to see a linear pattern because we addressed that the equation was in fact linear. But there is, of course, going to be one major difference between the linear equations we saw back in section 6 and what we're going to be seeing here. And it looks like I can actually maybe fit one more point on here. So let me go ahead and put another point on here. Let's put on here 5, 10. And of course that will continue. So I have that one more spot up there at 5, 10. And that would complete the graph of f. The temptation is going to be to connect the dots, because that's what we've been doing the majority of the semester. Back in section 1 is where we saw this exact type of function defined for us when we were dealing with only the natural numbers. Because we're dealing with only the natural numbers, it ends up providing a different type of graph. This is not a continuous graph, this is discrete. So when we talk about the graph, I'll go ahead and write that word up here. It is discrete, and it is not continuous. So all we get in a discrete graph is just these individual points, and we can say that there's a first point, second point, third point, fourth point, so on, and the pattern would continue as long as we needed. This is representative of a sequence. Definition will follow shortly.